China is about to pull off a space mission so bold, it sounds like science fiction. Tianwen-2 will chase down a mysterious asteroid that might be a chunk of the moon, then head straight for a bizarre comet with multiple tails. 2 cosmic targets, 1 epic journey, and nearly a decade of discovery. This isn't just exploration, it's a double shot at rewriting what we know about the solar system's past, and maybe even Earth's own origin story. At the center of China's Tianwen-2 mission is a small, enigmatic space rock called Kamoʻoalewa. Officially designated 469219, this near-Earth asteroid is far from ordinary. It belongs to a rare class of objects known as quasi-satellites, bodies that follow a synchronized orbit with Earth, remaining nearby but never truly orbiting our planet. Its peculiar horseshoe-shaped path around the Sun allows it to drift close to Earth for long periods, making it a celestial companion of sorts, but one that's often overlooked. Discovered in 2016 by the PANSTARRS 1 telescope in Hawaii, Kamoʻoalewa quickly caught the attention of astronomers. Although it only spans between 40 and 100 meters in diameter, what it lacks in size, it makes up for in mystery. Observations made using Earth-based telescopes in recent years revealed that the asteroid reflects light in a way that strongly resembles lunar basalt, the same volcanic rock found on the Moon's surface. This discovery has led to a fascinating theory. Kamoʻoalewa could be a fragment of the Moon itself, ejected during a violent impact in the distant past and now quietly orbiting near us. Tianwen-2 will attempt not just to visit this asteroid, but to collect physical samples and return them to Earth. The spacecraft is composed of 2 main parts, an orbiter, which handles navigation and scientific observation, and a re-entry capsule, which will safely carry the samples home. To extract material from the asteroid, the probe is equipped with a flexible toolkit that includes a robotic arm for hovering collection, a spinning brush for surface sampling, and a set of mechanical legs capable of anchoring and drilling into the rock if conditions allow. Because Kamoʻoalewa has almost no gravity, precision and adaptability are key. The spacecraft will orbit the asteroid, select the best sampling method based on real-time data, and eventually send the capsule back to Earth, with a planned landing in late 2027. After delivering its asteroid samples for return to Earth, Tianwen-2 is far from finished. The spacecraft will maneuver into a precise trajectory, using Earth's gravitational pull and a calculated flyby to launch itself deeper into space. This next phase of the mission targets one of the solar system's most puzzling objects, Comet 311p/PANSTARRS. Unlike traditional deep space missions that complete a single objective, Tianwen-2 transitions seamlessly from asteroid explorer to comet investigator, showcasing a level of mission endurance and complexity rarely seen. 311p is not a typical icy wanderer from the outer reaches. It resides in the main asteroid belt, orbiting between Mars and Jupiter, a region where comets aren't expected to behave this way. When 311p was first observed, it surprised astronomers by developing multiple dust tails, which appeared and disappeared unpredictably. This strange activity forced scientists to reconsider how comets are classified, and 311p was labeled a main belt comet, a rare hybrid showing traits of both rocky asteroids and volatile-rich comets. Its strange behavior raises critical scientific questions. Why would a body in such a warm, inner part of the solar system suddenly behave like a traditional comet? Is it shedding material due to rapid rotation, surface cracking, or sublimation of hidden ice pockets? The answers could reshape theories on how essential materials like water and organics arrived on early Earth. Some researchers believe that bodies like 311p may have delivered these ingredients, seeding planets with the building blocks of life. Tianwen-2 is outfitted to investigate thoroughly. It will map the comet's structure and monitor its activity using a suite of sophisticated instruments. These include multispectral and infrared sensors, radar imagers, magnetometers, and particle detectors capable of analyzing both dust and gas emissions. Notably, Russia's Space Research Institute has contributed to the spacecraft's particle analysis tools, adding an element of international collaboration to the mission. This phase of the mission is expected to continue for 6 years, with the spacecraft shadowing the comet through its journey around the Sun. Tianwen-2 represents more than just a scientific expedition. It's a technological, strategic, and symbolic leap forward for China's place in interplanetary exploration. It's also a signal to the world. China isn't content with following in the footsteps of others. It intends to chart its own course and raise the bar while doing it. From a technological standpoint, the mission tackles challenges few countries have dared attempt in a single flight. First, it involves a multi-mode sampling system capable of adapting in real time to an asteroid surface, a feature not even OSIRIS-RX or Hayabusa 2 used in full. Second, it performs 2 interplanetary rendezvous with very different bodies, which requires separate mission logic, trajectory planning, and propulsion management. Third, it includes China's first second cosmic velocity re-entry, where the return capsule will enter Earth's atmosphere at approximately 12 kilometers per second, faster than any Chinese spacecraft has ever returned. The China Aerospace Science and Technology Corporation, CNSA, has been preparing for this with high-altitude parachute tests and heat shield validation campaigns since 2023. Their engineers have also designed Tianwen-2 with autonomous systems to handle long-duration navigation, mid-course corrections, and target acquisition, essential for the nearly 10-year timeline. Strategically, the mission solidifies China's position as a peer to NASA, ESA, and JAXA. With Tianwen-1 already orbiting Mars and the Zhurong rover still on the Martian surface, China is executing a long-term planetary roadmap that includes Tianwen-3, a planned Mars sample return by 2028, and Tianwen-4, an ambitious Jupiter system exploration with a possible Callisto lander and Uranus flyby. Perhaps most importantly, this mission resonates with symbolism. Tianwen, which translates to heavenly questions, comes from a classical Chinese poem that ponders the mysteries of the cosmos. It's a poetic banner under which China is making bold moves, asking cosmic questions not through myth or metaphor, but through hardware, data, and science. What makes Tianwen-2 revolutionary is how it bridges scientific frontiers with national ambition. It's not just collecting space dust, it's pioneering a model of space exploration where missions are flexible, long-term, and multi-purpose. That could become the blueprint for future interplanetary missions worldwide. Tianwen-2 isn't just another space mission. It's a bold declaration that deep space is no longer the sole domain of traditional powers. By targeting both a quasi-moon and a hybrid comet, China is taking planetary science to the next level. This mission blends cutting-edge engineering with cosmic curiosity, offering answers to questions about our origins, our moon, and the evolution of the solar system. Whether it succeeds or not, Tianwen-2 marks the beginning of a new, multipolar era in space exploration, where the next big discovery could come from anywhere on Earth. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below.